In this video, I'm going to answer one of the sample papers of the world famous the Maths Kangaroo test. It's a maths competitive examination that is conducted across the globe in the field of mathematics. And this is a sample paper of year 2023, and this year Maths Kangaroo test is due in the month of April, but there are some schools who have already completed in the last week of March. So this question belongs to grade 3 and grade 4 students, and this is how it looks like. So this question paper will have totally 24 questions, and this is a 1-hour examination. So question number 1 to 8 will consist of 3 points, 9 to 16 4 points, 17 to 24 5 points. If any question is left unanswered, no marks are deducted, but there is a negative marking. For each incorrect answer, a 1/4 marks will be deducted. So very popular maths exam across the globe, and this exam is recommended. Every school must conduct this exam in there, because I just saw the question papers. All the question papers I have seen in descending order from 2023 until some 5 years question papers for each grade I have seen. And they are so much of thought-provoking questions, like the world of rote learning. In that time, we have this kind of question papers for school-going children, so it's a very good thing. So let's begin. The first question. The first question states that there are 5 children, each light the candle at the same time. So here you see A, B, C, D, E. So these are 5 children who are lighting the candle at the same time. That means the candles are of same height, same kind, and they lighted the candle together. Then Lisa, there is a child who blows out the candles in different times. Now they look as shown in the picture. So Lisa blew out all the glowing candles, all the candles which were lighted. She blew them in different times. The question is, which candle did Lisa blow out first? So very simple, which candle did Lisa blow out first? So the one candle which Lisa blew out first will be less burned. So you see the height of candle D. Height of candle D is the tallest. So tallest means it's less burnt. And why is it less burnt? Why? Because Lisa could blow this first. That is why the answer is option D. Answer is option D. Nice question. Coming to second one. 2 markers with a question mark have same value. You see here, we have these markers, 20 mark, 10 mark, 10 mark, and these are the 2 unmarked. There's no number is marked. And then there is 1, and these all sum up to 51. So let's take a vague guess what it is. 20 plus 10 plus 10, so that's 40. And this is a 141. So that means these 2 missing numbers should sum up to 10. Because 41 plus 10 is 51. So that 10. So the question is, which value do you have to use instead of question mark so that the calculation is correct? So question mark, same kind of question mark. So the 2 missing numbers should be the same number. So I guess it should be number C, because 5 plus 5 is a 10. So that is the answer for second question. Moving ahead, question number 3. A black disc has 2 holes. On 2 holes is placed on the top of a dial of a watch. You see right side there is a 2 hole on one, this the dial. If you imagine that it is placed over this dial, the hole is on 1 and hole is on 5. Okay. So there is a certain thing you understand now itself. So the holes are placed where, you see, if that black plate with the 2 holes, see I'm writing H1 for hole 1 and I'm writing H2 for hole 2. If that is placed on this blue dial on which 1 to 12 numbers are written, so in a particular way, the holes are on 1 o'clock and 5 o'clock. That means that there are 3 numbers between 1 and 5 that you remember. Now the black disc is turned according to the question. They say that which 2 numbers can be seen at the same time. So right now at the same time you see number 1 and 5. So now which numbers you can see at the same time? So for that we can choose from the options. Like if you choose the first one, 4 and 9. See, 4 and 9. There should be between 1 and 4, there is a 2, 3, 4. 3 numbers, remember. If 4 and 9, you see there are 4 numbers. So the first option is not possible. 5 and 10. Let's see, 5 and 10. Again, 4 numbers between them. That's also not possible. Coming to the third option, 5 and 9. Let's see, 5 and 9. Now you see between them exactly there are 3 numbers. So between 1 and 5 there were 3 numbers, 2, 3, 4. So the gap between the holes is only 3 numbers gap. Here there are 3 numbers gap between 5 and 9. So the answer is option C. Answer is option C. Moving ahead, fourth question. Alice. Alice has 4 jigsaw pieces. You see jigsaw piece of 1, 2, 3, 4. Which 2 she put together to form this square? So this square is formed. So which of the 2 you will see, you put them together so that you get this. So this kind of things are very easy if you just see the options. In the option 1 and 2. Option 1 and 2. Let's see how they fit in if I take option 1 and 2. Option 1 and 2. Option 1 and 2 is not possible because option 2 is a height, you see. This much extra height is there. That will overlap. No, so this part will be overlapped. So option 1 and 2 not possible. 1 and 3. 1 and 3 is perfectly not possible. 2 and 3. 2 and 3, no. Again, this is the overlapped position, not possible. 2 and 4. 2 and 4 not possible because they look alike. Both of them will be superimposed with, there will be one extra part coming up on this. Okay. So only option left is option E, and let's check option E works out or not. Option E is 1 and 4. When you attach 1 and 4, does it form a square? Perfectly, you see, I'm just doing this shaded 4. This 4 I'll bring in here, you see, here it comes, here you see. Now you see the striped part. Does it look like this? Fourth part. The striped part, fourth part, that will perfectly fix in here. So option E is the right answer for question number 4. Moving ahead, fifth question. Maria switches lights on and off according to the given plan. How many minutes in total? How many minutes in total? There are exactly 2 lights at the same time. So very simple. You have green, orange, blue lights, but there should be 2 lights together. See here. This is 2 lights. But here 3 lights are there. So we'll not choose the 3 lights. We'll choose only 2 lights. So 2 lights, 2 lights, 2 lights. 2, 2, 2, 2, 2. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. For me, 8. Okay, so there are exactly 8 minutes. You will see 2 lights where there were exactly 2 lights at the same time. So option C, fifth question, option C is the answer. Moving ahead, sixth question. Christoph folds and see through a piece of foil along the dashed line. So you see the main picture is this one where I'm putting an arrow, and the paper is folded along this dotted line that I'm drawing. Okay. So this is the question picture, the arrow showing the question picture, and that question foil is folded by the dotted line that I'm showing right side. You see it is folded like this. After folding, what can he see? So there are times for A, B, C, D, E. 4, 6, 2, 7, 7.89, 3.55. 6.04. So which number comes out? So I see sixth question as you fold. Okay, so that is folded, so you get here, okay, and then and that falls here. I just do this again. The last one, that 0 will fall the bottom, so the last digit looks like 6. Last but 1 will be reverse 7, and here this one comes here and this one comes here. Looks like 406. So sixth question, A choice. Okay, so give a thought, you will understand that it is 406. Let's move on. Seventh question. Anna has 4 discs of different sizes. She want to build a disc. She want to build a tower using 3 discs. Oh, she has 4 discs: yellow, orange, dark orange, dark orange. That's orange only, and then blue. Okay, but she want to use only 3 discs. Smaller disc is always lies on the top of bigger disc. Okay, just like Hanoi Tower of Hanoi. The puzzle looks like Tower of Hanoi. The question is, in how many ways are there for Anna to build this tower? So out of the 4, any 3 are taken. So let me choose. She chose disc 1, she chose a disc 2, and she chose a disc 3. Okay, so these 3 discs she has to put one above the other, such that there is always the smaller disc always has to lie on the top of bigger disc. So in how many ways this is possible? So the total number of ways that this arrangement is possible is, let me use some formula here. Tower of Hanoi, the number of ways in which the arrangement is possible is calculated using the formula 2 to the power k minus 1. And what is k? K is the number of moves of the disc number. How many moves the disc number? So that is it. So here 3, k is the number of discs actually, and n is the number of moves in which this arrangement is possible. Okay, so I'm just doing this. N is the number of ways in which this work can be done, number of ways, and k is the number of discs used, So number of ways this arrangement can be done is, this formula is a very popular formula for solving the Tower of Hanoi quiz, or a puzzle, Tower of Hanoi puzzle. 2 to the power k minus 1. That is 2 to the power. There are 3 discs. Anna has used 3 discs, so 2 to the power 3 minus 1. That's a 2 square. That's 4. So in 4 different ways, the arrangement of the discs can be done. Moving ahead, question number 8. In question number 8, Daniel sticks these 2 pieces of paper. One is a semicircle, another is a quadrant of the circle. On this black circle, oh, this is that black circle where I'm putting the arrow. On this black circle, which picture does he get? Oh, depends how it is being stuck. So there is a one semicircle I see in option B, that semicircle I see, and in option E also I see a similar semicircle. And then there is a quadrant. So the quadrant in B, this is not the quadrant. So B option is not possible. But in E, elephant E, there is a quadrant. So I see that most, and that too, these 2 pieces are stuck on black. So the black background, you see I'm putting 2 arrows where the black background is seen. So very clearly it's not option A, because option A looks like that, but The semicircle is a gray color, but here the semicircle is pure black, so it's not possible. Option B is not possible, C no, D no, and it's perfectly option E. So that's the right answer, because on the black background, you can see the black background also. You see these are the two black backgrounds. This is that quadrant and this is that gray color semicircle. Okay, so option E. Moving ahead to the 4 marks questions. 4 mark questions. Question number 9. Using pieces A, B, C, D, E. See A, B, C, D, E. So here A, B, C, D's are not options. These are the pieces of paper. A, B, C, D, E. These pieces of paper, one can fill the shape completely. So here, this is that. Okay, that shape has to be filled. Which of the pieces lie on the dot? See here, there is a dot shown in the base. There is a dot shown there. They say out of A, B, C, D, E, which piece is on the dot? So it's very clearly, option E. I'll show you how it is option E. Option E, this option E is this is square. On that, this a dot is there. And then this one and this one. So that's option E. And the other pieces, where are they going to fit? Okay, just wait. Option E, this one, and like this. This is option E. Okay, so option E. This is the E piece. Where are the other pieces? Other pieces. I just showed the other piece. Okay. Wait. I just do a small correction. This dot is here, E. I'm showing you here. That is it. So should not, because I just saw the corner piece. C corner piece is there. Okay. So where is that dot? The dot is there on E. Okay. And E piece, I'm drawing it on that. That is E piece. That's E. This is E. And C is this one. Here that the C, and then there is D. Here D. This is a D. And coming to A is all the way a partition here. This is A. And this part where I'm writing outlining, that is B. So those 5 pieces will fix on that. So which is the answer? Answer is E. Moving ahead, question number 10. Question number 10. The 6 ways of the scale weigh 1, 2, 3, 4, 5, 6. Rosie places 5 weighs on 2 scale pans, so they balance. The 6th one weigh left aside. Which weigh is on the left side? Okay. We have to tell this piece. That piece is which one? So you see here, I'm writing on the jars that you see on this picture. So this is 5 already mentioned. This can be 2, this can be 3. So that sum is 10. So left side, it's 10 kilograms. Right side, if one of them is 6, other one is 4. So that makes 10. Okay. So that makes a 10, but okay, then let's see what ways are there. 6, yes, 5, 4, 3, 2. Okay, so all these ways are consumed except 1 kilogram weight. So the question mark jar is a 1 kilogram, because on the weighing machine, 10 either sides at 10 kilograms are well balanced. So what is left is the 1 kilogram. So what is this jar that is kept aside? The jar that is kept aside is a 1 kilograms. Okay. So that's a 2, 3 and 4. Okay, so this is the 1 kilograms. The option is option A. Option A. So question number 11th. The diagram shows 4 cars 1, 2, 3, 4. So here there is car 1, car 2, car 3 and car 4. The arrows shows where the car moves in the move to in 5 seconds. We have to tell which cars will crash into each other. So let's see how much will they move. Okay, so right about car 1 and 2. So car 1 and 2, look into their directions, the distance between 1 and 2. So if car 1 moves one step, by the time car 2 moves one step or 2 steps, by the time car 1 must have reached this location. So they will not cross each other. So it's not 1. Car 1 and 3, 1 and 3 also will not move to each other, because in next step car 1 will reach up to this and car 3 will reach up to this. That means they have already crossed each other. It's not 1 option, not 2 option. 1 and 4. 1 and 4 are going parallel to each other, so they will also not cross each other or crash into each other. About 2 and 3. Perfectly. 2 and 3 are in the same line to each other, so they will crash each other according to the information. So for 11th question, the answer is cars 2 and 3 will crash into each other if they move in the direction, the given direction on that dotted plane. Okay. Coming to 12th question. North of street A, there are 7 houses. 7 houses. So here, this is 7 houses. East of street B, there are 8 houses. I'm just following the directions and writing the number of houses. South of street A, this is street A. Street A, and that's street B. There are 5 houses. The question is how many houses are there to the west of street B? That means how many houses here? So very simple, you see, north south total number of houses is like these are well planned cities. 7 plus 5, 12. In that case, east west also there should be 12 houses. So 8 plus 4 is a 12. So our answer should be option A. 12th question, option A is the answer. Yeah, moving forward, 13th question. 13th question, in a queue in front of a ferry, there are 8 cars and 19 people in total. So there is a ferry. I'm just drawing the ferry, a kind of boat. Okay. And in front there are 8 cars. So 1, 2, 3, 4, 5, 6, 7, 8. And there are 19 people in total. So there are either 2 or 3 people in each car. The question is how many cars? There are exactly 2 people. So that means 3 is the maximum number of people. So what I'm doing is I am filling the cars with 2 people first. So here 2. Okay, here I'm writing 2, 2. Because 19 is the count. No? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 3 cars which has got 3 people each. And there are 5 cars which has got 2 people each. So 13th question, the answer is 5. So there are 5 cars. There are 5 cars in which there are exactly 2 people. That is 13th question. Moving on to 14th question. 14th question, 6 beavers and 2 kangaroos. So beavers are So there are 6 beavers and 2 kangaroos standing on the field in order. Okay, 6 plus 2, so 8. So these are those 8. Beavers are rodents. of 3 animals in a row, there is always one kangaroo. Oh, so on which of these numbers stands kangaroo? We have to tell this. Nice kangaroo test and the kangaroo question. So let's do this. Say the first has, there is a beaver, then there is a beaver, then there is a kangaroo, then beaver, then beaver. That means out of every 3 animals in a row, there is one kangaroo. So here, that is it. And then there is a kangaroo, then there is a beaver, then there is a beaver. This is the order. So out of which number stands kangaroos? Kangaroo stands on 3rd and the next one 6th. So third is the answer. Coming to 15th question. 15th question, Hanny wants to color circles in the diagram. When 2 circles connected by a line, they should have different colors. What is the minimum number of colors she needs? Okay. So to answer this, I use the RBG colors. I'm writing here R, B, G, red, green, blue. And then this is R. And this is already G, so I'm writing here blue. And then here I'm writing R. And then here I'm writing R. So what's the minimum number of colors she needs? See, I have kept all the RBGs with no common color, no connecting color. So we need only 3 colors, option B. Only 3 colors, option B. Coming to 16th question. 16th question, a building block is made up of 5 identical rectangles. So here 1, 2, 3, 4, 5. 5 identical rectangles which are in this form, where I'm putting a tick mark, that form. How many patterns shown below can be made with 2 such building blocks without overlap? That means they should not overlap. I clearly see, except this second picture, you see here overlapping is done. You see how overlapping is done. See, this is that 5 set, and which is the other 5 set? This is the other 5 set. 2 bricks are overlapping. Okay, these 2 bricks are overlapping. So except the second one, all of them. So how many can be formed? 1, 2, 3, 4. So 4 such patterns can be formed. So option D. Option D. Okay. Coming to 17th question. 17th question is an underground line has 6 stations, A, B, C, D, E, F. Train stops at every station after reaching the end line A and F. That means A is a station, F is a station, and this is the point where the train starts continuing backward after reaching them. So in which station with the train conductor starts his journey from B. That means train starts from A and comes to point B, and here the conductor gets in. So the train starts from A, say for example, and comes to station B, and here the conductor gets in. Now then it goes to C, stops a D, stops a E, stops F, stops again, comes back F, E stops, D stops, C stops, B stops, A stops, again moves forward. That means it stops in every station. But the conductor got in to the train at station B. So in which station will be the 46th stop? For 46th stop, starting with a B, 46th stop for the conductor. Starting with B, forward there is a 1, 2, 3, 4. So 4 stops forward, plus backward 1, 2, 3, 4, 5, 6, backward 5. Again forward another 5. So I'm doing up to 46 number I reach. Okay, and then I'll see that when this 46 came. Then okay, I'm just writing so that we understand which is forward, which is backward. So because conductor started from B, so 4 steps forward, up arrow, then 5 steps back, 5 forward. So until now it is 14. 5 back, then 5 forward. So this is 24 plus 5 backward, 5 forward, 5 backward. So 10, 15, 20, 25, 30, 35. 35 plus 4 is 39. So plus 5 forward, 39 plus 4. 39 plus 4 is 43. 43. So, okay, let's see, you have a count once again. So, this is a 10, 15, 20, 25, 30, 35, 40, 44. Okay, 44. So, next 5 back, that will take to 46, but only that will take to 49. So 5 back is not necessary. Plus 2 back. So 2 back means what? See, I was putting forward for B, C, D, backward for F, E, D, C. So last I got 2 back. 2 back means what? The train must be at F and 2 back. 1, 2. So 46th stop is D. 46th stop is option D. Option D. Okay. So you look into this forward. Up arrow means forward. Means B after C, D, E, F. 4. Next 5 back arrow I kept. No, down arrow. Means from F 5 back means coming to A. Again 5 forward going up to F like that. So when I counted 46th stop, it came at a D. From F 2 back. Okay. That is 76. 17th question. 17th question answer is D option. Coming to 18th question. 18th question, Rebecca folds square paper. Okay, so there's a square folding is given. What could be the paper look like now? Oh, that folding, that cutting. I guess. Yeah, it is clearly option B. Okay, so as you take a paper and fold like that, you just get option B. 19th question. 3 boys enter a room one after another. Herman is not the first, Felix is not the second, Clement is not the third. How many different orders are there for the boys to enter into the room? Okay, so I'm just creating the arrangement where 3 boys will enter the room. Okay, so that is first, second, third. So Herman is not the first. So here it's not Herman. And Felix is not the second. Okay. Clemens is not the third. That means Herman can be second or third. Felix can be first or third. Clement can be first or second. So how many different orders are there for the boys to enter? So each one of them can enter in 2 different ways, because Herman cannot enter the first way but can enter in 2 different ways. Felix also 2 different ways. Okay, so how many orders are there for the boys to enter into the room? So each one of them have 2. Each one of them have 2 different ways, because for each of them 1 way is not allowed. So 2 of them. So 19th question answer is B. Coming to 20th question. 5 clocks are hanging on the wall. One of the clock is 1 hour ahead. Another clock is 1 hour late. And only there is 1 clock that is correct. 2 clocks have stopped working. Which clock is showing the correct time? So what a wonderful question. So how do you identify? For identifying, just see clock 1. For clock 1, think that clock 1 is right. If clock 1 is right, based on this, we will guess the others. So one of the clock is 1 hour ahead. Which clock? See, clock A is 6 o'clock. So which clock is showing 7? Okay, 1 hour ahead. Another clock is 1 hour back. Is there any clock that is showing 5 o'clock? None of them. So option A is not possible. Option A is not possible. For option B, say clock B is correct. So 2 o'clock. If this is correct, then there is a clock that is showing 1 o'clock. See, no clock is showing 1 o'clock. So option B is also not correct. Let's see option C. If C is the correct clock, then there is one clock that is ahead, 5 o'clock, another 3 o'clock. Do we have 5 o'clock and 3 o'clock? We have 3 o'clock, but we don't have 5 o'clock. So 3 is also not correct. 3 is also not correct. About D. Maybe D is correct. Let's see. For a D to be correct, there should be a clock that shows 4 o'clock. There shows 2 o'clock. Do we have such clocks? Yes and yes. So, and there are two clocks which are not working. Maybe clock A and E is not working. So for 20th question, correct answer is a D. 20th question, correct answer is a D. Now 4 more questions to go. Let's see. 21st question. Adam has 9 marbles. Brenda has 9 marbles. Oh, both of them have 9 marbles. Each together they have white and black marbles. Together they have white and black marbles. Okay. 8 white and 10. Okay. So actually 9 plus 9 is same as 8 plus 10. So 8 white, 10 black. Okay. Brenda has twice as many marbles, as many black marbles as white marbles. Okay. So I'm just trying to create an equation. So Adam has 9 marbles. Brenda has 9 marbles. So A plus B is actually 8 white plus 10 black. So we got our equation. We'll see based on the equation. Brenda has twice as many marbles, black marbles as white marbles. So I'm just creating a table for Brenda and Adam. For Brenda, my equation is X be the white marbles and 2Y is the total number of white marbles. Together, Brenda has 9 marbles. And Adam has, Brenda has X white marbles, 2Y number of X white marbles, 2Y number of black marbles. Together, she has 9 marbles. And about Adam has some white marbles and black marbles. Let's see which equation suits well. So say for example, y is 1. Then when this equation is suitable, y is 1 means 2. 2 into 1 is 2. So x should be 7. So 7 plus 2 times 1 is 9. So that is okay. So x1 and x7 and y1. So here white marbles 7. If white marbles are 7, yeah. So from here you understand that Brenda has 7 white marbles because the equation is satisfied with this. 7 plus 2 times 1 is 9. So if Brenda has 7 marbles, then there are totally 7 white marbles, then there are totally 8 white marbles. So Adam will have 1 white marble and it will have remaining because each one of them have 9 marbles. No, so 8 black marbles. 8 black marbles. So if it is 8 black marbles, then only it becomes 9. So how many black marbles does Adam have? According to the first option, Adam has 8 black marbles, which is not one of the choices. Okay. Now let's see any other choice because this option is not there. Then we'll see for some different value of y. So if y is 2, 2 times 2 is 4. So then x will become 5. Its meaning is Brenda has 5 white marbles. In that case, Adam should have 3 white marbles because totally there are 8 white marbles. And then each of them have totally 9 marbles. So 3 plus 6. So Adam has 6 black marbles. So in this option, yeah, 6 is there. So Adam has 6 black marbles. That's the 21st question. Moving ahead, 22nd question. Elsie has 2 machines R and S. If she puts a square piece of paper into machine R, it is rotated. And see what happens here. The sequence is shown here. So this dot after rotation, after like this rotation, the dot comes into this location. Okay, that's a picture wise understanding. If she puts the piece of paper into machine S, it is printed on, like now see the second diagram. The dot remains there only, but the club of cards gets printed for S. Now she wants to produce a picture of this kind, means a dot at this location and picture rotated. So that means R is for rotation, S for printing the picture. So in which order Elsie use the machine so that she gets this picture. Okay, so it should be okay. So the dot should travel here and then finally here, and this picture has to rotate. Okay, so let's see from the choices. SRR. Okay. More suitable is for 22nd question is option B. So the dot is here, then R. If it is R, the dot travels in this location. And then S, then comes in S. If it is S, then the dot stays there and the picture of the club comes like this. And now if it is R, then the picture stays, the club picture stays, only the dot shifts to one place, that is the new place. So the correct option is option B. Coming to 23rd question. 23rd question, teacher wants to write the numbers of 1 to 7 on the circles. He writes exactly one number in each circle. When he adds up two numbers of circles that are next to each other, he gets the number written between the two circles. Okay, so these are the numbers written. Which number does he write in the circles with question mark? So here which number? So we have to create a sequence of equations to identify which number is this. So when you see, you will get the number should be 4. The number should be 4. Okay, now you verify this is right or wrong, because when he adds up the two numbers of the circles next to each other, he gets the number that is written between the circles. Right. When he adds up two numbers of the circles, so this number and this number, when it is added, you get the number 4. So option this. You should try different combinations of equations. When I tried, I got this different number combinations. Okay, so this number is 4, and give a thought on this. That is going to be 4. 4 is the sum of this number and this number location, and to get this numbers you have to use a 9 4 and 9 8, and then there will be one connection with a 9 and 8 and 8 and 9. Then you get this equation. Coming to the last question, Maria colors exactly 5 cells of this grid in gray. Then she has her 5 friends guess which cell she has colored in, and their answer are 5 patterns A, B, C, D, E. Maria looks at the pattern and says, one of you is right. The others have each guessed exactly 4 cells correctly. Which pattern did Maria paint? So Maria painted, you see, according to this, Maria painted the last option. Okay. So you have to, yeah. So look into the options. The most appropriate answer is the last one. So give a thought, and those are the answers.